We are ready.
Okay, the next speaker is Cecilia Hertz from Sweden. She has a master degree in industrial design from Lund University of Technology, Lund University, Sweden. In the last 2 years of her education, she focused on space design projects in cooperation with JSC, NASA, and European Space Agency. In 2001, she started Umbilical Design in Stockholm, Sweden. It's a company focusing on design and architecture for space and extreme environments. And Cecilia will be giving her paper entitled A Crew Return Vehicle Interior Layout. Immediately following Cecilia's presentation at 4:30, we'll have all the authors back and a couple of authors from yesterday, and we'll do an international space architecture panel discussion starting at 4:30. So,
okay. Thank you very much. First, I would like to say that I'm very happy to be here today and to present the crew return vehicle interior layout, design process, and project. Of course, it's very challenging to present 5 months of work in 20 minutes, but I will try to summarize some highlights of the project. And after the presentation, I will have a short movie of about 5 minutes, so you also get to experience some of those environments that we have visited. So this paper that I will present to you is based upon my diploma work together with 3 other students from the Institute of Technology in Sweden. And it was a cooperation with the X-38 project at NASA and at European Space Agency. And supervision from the university was by Professor Lars Reuterswerd and Dr. Maria Nyström. And just like a little history, it's thanks to Dr. Maria Nyström that this connection is between Sweden and Johnson Space Center NASA since 1997. First, I would like to introduce you a little bit to the project, the Crew Return Vehicle, and it's a crewed spacecraft, a lifeboat for the International Space Station, and it will have the capacity to bring 7 crew members back to Earth in an emergency situation. The project, the X-38 project, I should add, has been shut down, and they are looking into other vehicle concepts. But this vehicle were supposed to be 9 meters long and 4.5 meters at the widest point, and the weight should be 7 tons. And it should be transported with a shuttle to the International Space Station and docked by a berthing adapter. And it should take about 3 minutes for it to be activated so the crew could leave the station in an emergency. And back to Earth, it would take between 3 to 9 hours, depending on what of the 8 preset landing spots that were decided for this specific flight. The aim of the diploma work was to produce and visualize solutions for an interior layout of the CRV cabin that support and ensure a psychologically and physically safe trip for 7 crew members in any condition from the ISS back to Earth. We set up 4 design levels, and the priorities for this work was focusing on design levels 1 and 2. So the most important was design level 1, concept and configuration of the CRV cabin, and design level 2, architectural design and layout of the interior. We also did some work for the design level 3, functionality design of the products and interior, but the design level 4 we decided should not be in the time frame of the project, as it was only a project of 4.5 months. To identify and learn from other environments, we did a lot of field studies. So we visited 12 different locations in Europe and in the United States to study vehicles and extreme environments with similarities to the ISS and the CRV. The CRV project were selected as one of 30 European student projects to participate in the European Space Agency's Parabolic Flight campaign in Bordeaux, France. So that was an amazing experience and was really good for the project and the final outcome and solutions. For the project, we made an aluminum mock-up, a full-scale mock-up of the crew cabin, of the 2 operator seats and the berthing adapter. You don't see the berthing adapter here, it's only the 2 seats and how the volumes were set for this testing. Here you can see the mock-up in the parabolic flight plane, an Airbus 300. So we tried it out during 30 parabolas and had different testing procedures. So that was very amazing, and it gave us a lot of very good test results for the final outcome. We also made a full-scale mock-up in foam, which was very helpful, and it represented the whole crew cabin. It was 4.6 meters long and 2.5 meters wide. So we could experiment. It was like an enormous Lego. So we could build and change and try out different solutions. And also all the items that were to be placed in the cabin we made out of foam, and we could implement it and try different configurations, of course with help from different medical doctors, as this was very much focusing on the medical part, also of course of the operators and the astronauts. We also made 2 mannequins. You can see one inside the crew cabin. We made 2 of them, one representing the biggest and one the smallest person to be flying in the crew cabin. That was to give us the idea of the different sizes of the persons to be included in our design work. So here is actually the result of the project. From the beginning, we started out from concept A. That was the original proposal, where we had four astronauts in the back. In the back of the vehicle, where also the entrance to the vehicle is. 2 operator seats were placed in the middle and 1 in the front. And in this concept, it was a flat floor with 7 seats mounted on the floor. In our proposal, we changed it. I will show you later how it looks in 3-dimensional. But it's not a flat floor any longer. That made that we could accommodate 2 pilots in the front and 1 medical supervisor in the middle, and that could care for 4 possibly injured people. And we also got a lot of space for the ingress and egress procedures. And also we got a lot of space here, so we easily could do maintenance of the vehicle. But I will come back to this shortly and give you a better 3D view. To handle the project, as there were many people involved, we made a visual tool that we call the funnel, and it illustrates the different ways by which information is gathered and how it's via different methods and tools is transformed into results. So as this was kind of explorative project, we needed to focus a lot of getting experience about this new area and also find ways of structuring the found information and find the right analysis approach. And after that, we decided what methods and tools to integrate in the project And after that, we could go into the design proposals and finally present the final result that we call the CRV interior layout slide. We also made something that we call a mental model, and it's create also to make a visual understanding of the project process. And it starts here in the middle. The rectangular boxes is the real project, and we created a mental model abstraction, as it's called, which we also had this very important dialogue with the reality all the time. And the methods and tools gave input to our mental model abstraction, and some outputs were not good enough to go to the design proposals, so it had to be as a regenerated output and be mixed again with new methods and tools. So the output was performed in design proposals and finally in the final result that I will give you later, and that was supposed and a desirable connection with the real projects to give influences. Here you can see from design level 1 the whole cabin, and the new configuration that we developed was divided in two major areas: the pilot area in the front and the medical area in the back. And here you can see that the floor is no longer flat, it's rather like a landscape with different volumes, and no flat areas is needed in the microgravity. So the two pilot seats are placed in the front of the steering cabin, and as I mentioned earlier, in order to be able to fit these two seats in the front, we take some extra volume from what was called the given floor level. And here is the medical seats, two on each side. And what we can't see here, but we'll see later, is that we had also movable medical rack placed. So 4 possibly injured people could get support during the flight back to Earth. In the middle, we placed what we call the spider seat area. It's for the medical supervisor, and it's placed on rails, and it's movable along the aisle in the cabin. And here you can see it's the full-scale mock-up without the roof, and we have placed the mannequin in the middle as the medical supervisor, and then we have the 2 pilot seats in the front, and the 2 medical seats on each side of the supervisor. And the benefits out of the diploma work configuration we have summarized, as it provides now the CRV with all necessary aspects to fulfill its function as a rescue vehicle. It also provides a calm working environment for the pilots, which are now placed in the front. And it enables a possibility to perform quality medical treatment of up to 4 possibly injured people. And it also enhances the possibilities to ingress and egress the vehicle, as the ingress and egress is here of the vehicle. And also, it's now more easy to access the lower parts for maintenance of the crew return vehicle. Just to give you an idea of design level 2, this is where we deal with interior volumes and how to use them in the most efficient way. So we placed 26 different items in the full-scale mock-up, also showing them in the 3D module and how they were placed in the full-scale mock-up, and also identify how many and the volume and where it should be stored. So I just give you 2 examples here, one from the survival kit, and the other one is the ISS oxygen tubes. But it's 26 different items, so I will only show you 2 today. And design level 3, we were more looking briefly at, and focusing on the product itself and the product versus the context of the interior design and the volumes were studied. And here you can see the medical rack that we suggested should be placed on rails. So both the medical seats on each side could be helped by this medical item. To give you some findings from the parabolic flight, it was, of course, a very good experience for the design results and how to come up with the final solutions. What we found out was that the volume utilization, the volumes feels so much bigger when you are in a microgravity environment. And that is a very good experience because on Earth, when we were rehearsing in the aluminum mock-up, it felt very cramped. But when we came up in the parabolic flight, suddenly it appeared it was a lot of space. And movements in zero gravity, it's extremely easy to move in zero gravity. That's also important to understand. And when it comes to work in zero gravity, we understand that it was always easier to be strapped in some way or to have some points to fix your body. And when it comes to the seats, we also brought up a vacuum bed to try out that as a possible seat, and it was giving a very good support for the whole body. So that is something to really think for future seats and future vehicle interior designs. And the last thing, the findings that we call the significant layout application protocol, is because we wanted to summarize the whole project in only the five most important findings. And what we find out is the CRV will above all be used as a rescue vehicle, and the new configuration offers capacity of giving high qualitative medical treatment to up to 4 crew members, and it provides also a flexible interior and volume utilization that supports efficient ingress and egress procedures. We also find it very important to take into consideration the psychological reactions of the crew members that might appear during the flight. And studies, it was also very important to study the entire chain of events from ISS evacuation to ground egress. And that, from all that, it has resulted in this new configuration. So, as a last conclusion, we found it has been very valuable to work directly with both NASA and European Space Agency and initiate the process together, and after that summarize the findings in the CRV interior layouts map. And the findings, it's important to say, are seen as future challenges. There is much work to be done, of course, and what we see is that the lessons learned could be implemented in other designs for microgravity environments. So this is the last picture, so I want to thank you very much, but we still have the movie I will show you. And I also want to say thank you to all, the acknowledgements for all people involved. It has been, I think, 50, 60 people, so they have not the room here. But especially thank you to Johnson Space Center and European Space Agency. So you can find the whole project on this website that I noted here. You are also, of course, welcome to contact me if you have more questions. So just a little short movie, and then we'll be finished. This is to give you the idea of some of the field studies that we have been doing. It's also a little bit from our parabolic flight. I won't cover the whole page, but drop test, how they work with the Kurutan vehicle, and also how it is attached to the space station. Here they take out a prototype of the CRV under the wing of a B-52. Then they make drop tests to try out the vehicle. So here comes the first parafoil, which is a small one just to reduce the speed. And then the world's largest parafoil is deployed. Here is from the parabolic flight. I can say that it was about 70% of the students that were not feeling good during this flight. But I was very lucky, and me and my student colleague had really lots of fun in there. It takes a little while before you can control your body because it tends to float away, and that's kind of mysterious feeling. You almost feel like a ballet dancer or something. You move very easily, and you could do things very quickly. And in the background you see what we call the birthing adapter, the cylinder that was there just to try the feeling of going through a cylinder. And everything was rehearsed on ground. We had 15 different procedures to try out during this 30 parabolas. How long is for each parabola? It's 20 seconds, but it's extremely long. So here is the last one actually. We were very, very happy. And you can see very soon that it goes very quickly from microgravity to gravity. So very soon you can see it here. It will just very soon fall down. So you better be careful so you're not in the roof region or something like that. Here we were visiting and looking at life flight helicopters at Herman Hospital in Houston. And we also had the medical doctor from NASA, Smith Johnston, with us, working very closely. This is what it's about, to explore details on Earth and see what we can learn from that. Here's Smith Johnston, the medical doctor from NASA. Here is also from ESTEC, from European Space Agency in the Netherlands, how we were looking at full-scale mock-ups and here's two short. That was Frank Levin, the Belgian astronaut. Here we tried it in virtual reality by ISS. So that's about all. So thank very much for your attention.
Okay, does anybody have questions for Cecilia? I have one real quick. As in my university experience, I do a lot of mock-ups with my students, and I'm very curious about these foam blocks. How do you enjoy working with foam? Is it easy to work with, and how big is the foam?
Yeah.
Get a hold of it?
It came a whole truck with this blue foam, I can tell you. So it was big sheets, 10 centimeters wide, and so we used 46 sheets to create the cabin. So it was quite easy to work with, but you get totally blue from the top of your head to your feet, and I don't think it's too healthy as well, as we were working with this heated, this is called, so you can,
A wire cutter?
yeah, wire cutter, so you get this nice smelling from this blue foam. So, but besides that, it's a fantastic thing to work in, and you glue it together also, I think, with something terribly dangerous glue. So I can tell you our professors and everything, they were not present, so we were working in a separate building. So, but besides that, I mean, for us it was a fantastic thing to work. And especially when we were suggesting a totally different configuration, I would have guessed that if we hadn't the full-scale mock-up, we had been really questioned and people should ask, we don't believe it works. So it was also an argument to do this. First, it was only to do a better design work and proposal, but now it's also an argument for this new proposal. And it's also very nice to have some, because it's very big. I mean, it's 4.6 meters long and 2.5 meters wide. So it's actually still on exhibition. So it has been on exhibition for 2.5 years now, the Kurtan Eco exhibition. So.
Any questions?
I have a bureaucratic question. Where was the source of funding for this?
Actually, we find the funding from different places. It was private persons. We also got some sponsoring from European Space Agency, from the Swedish National Space Board, and we actually got some help from a person that raised some money for us, because it was, as you understand, quite expensive. But everything like foam and whatever material we needed, we just phoned to different companies, and everyone just sent trucks with whatever we needed. So it was, people were amazingly helpful. So otherwise, that's why we had this list of acknowledgements to 60 people, I think, so in companies.
What is the next project? What are they doing now?
The next project on this specific one, or?
Both.
Okay, for this project, I just hope that, I mean, it's something it's an experience, and I learned a lot about how to work with volumes. So I mean, it could be implemented in any kind of vehicle or habitation design for space. But as I now have my own company since 2 years, I work with different projects, some related to space, but then it's more like looking at possible terrestrial applications and see what kind of space materials and space technologies that could be implemented in our everyday life. So, but of course I hope for some kind of continuation for this in some way.
Questions? Okay, we're actually, it's time to start the panel discussion, if I can have my
Okay.
Okay, our panel of international space architects consists of the speakers for today, and also 2 presenters who are presented at sessions yesterday. And Cecilia Hertz is from Sweden. Meinrad Versteeg is Dutch, Swiss combined. Yeah. And then Maria Durao is from Portugal. David Wong is from the UK, originally from Hong Kong. And then Martina Pini is from Italy. Just to start out, I noticed that a lot of the papers that we saw today, and also if I look back, I know David's paper was on a slightly different subject, but Meinhard, yours was also very similar. They had to do with the layout of interior, or the perception of interior space, or the design of interior. We have one that was the interior design for a space module, or a space taxi, which is unfortunately we don't have Claudia here with us. Then the crew return vehicle layout that Cecilia did. In your experience, I know that a lot of space architects are also working on system integration and structures, construction, mission planning, and things like that. Is this, if I could just get your perception on you and the associates that you're working with, are you, is this the direction that you chose, or is there, is this the kind of project that you feel like you can provide the most contribution? Just kind of give me an overall feeling about these kind of interior type projects. Anyone who wants to go?
Well, for me it was a practical reason because
You can use the microphone.
for me it was a practical reason because when I started my thesis in Italy, it was very difficult to find materials about space engineering and space things. And so I decided to go for an interior design for a module because Alenia was there. I could get drawings of the modules, and also I could manage an interior design by myself without support. But I'm working on other projects now about structures and about inflatables, which is the focus of my next research.
So just along that, before we move on to others, Martina, your specialty is architecture. So it isn't, you're very much just interested in structural structures and other things that are more of an overall integration, as opposed to some of the other specialists here, industrial design, or for instance, Maria with very much a scientific background in color.
Yeah. Actually, I'm interested in building shapes, no matter what, and if it's interior design or if it's a structure, I'm interested in the pure aspect of architecture.
Well, actually back to Scott's question about, well, although in my paper I didn't produce any specific design in my paper yesterday, but I feel that the first thing which attracted me to space.
Let me just interrupt you real quick. David did a paper yesterday on the discipline of space architecture. So he was more talking about the overall discipline and some of the things that we discussed last year in the World Space Congress in our symposium.
Yeah, so I feel that the first thing which attract my attention is how does a person live in space. We all know there's like a lot of the microgravity environment or extraterrestrial environment are very unique, and as an architecture student, I find it very inspiring to think about how do we live in microgravity and how do we respond to these this condition. And as an architect, how do we design our interior space to it? So I think it's natural for us to start from designing something which is tangible or touchable, or just as a module. That's what I say.
So David, do you think, how do you think that will affect your design of terrestrial architecture, or do you have any interest in that at all?
Yeah, it certainly definitely have an impact of how I perceive space on Earth. Because in microgravity environment or in space environment, there are something which it makes you aware of some situation which you take it for granted on Earth. For instance, like the lighting. On Earth you expect that every day you have days and nights and 24 hours, but when you come to orbital kind of environment or on other planet, that may not be the same. For instance, on the low Earth orbit, on ISS orbit, you get sunrise and you get the cycle 90 minutes. So it's sunrise and fall every 90 minutes, and it's something very strange because psychologically you feel that it's a day already, but it's not. And I mean, there's a lot of and then it kind of like makes you aware that something like is small. I mean, it's something that you generally ignore on Earth, but it's actually could be quite important to when you consider the design of architecture.
It's so difficult to separate knowledge, areas of knowledge. So easy and so difficult. For example, when you think of color, we can look at color from so many different perspectives: from the physics, from the psychology, from the physiology, neurology, history, anthropology, and so forth. So many. And yet, here today, I was fascinated because it's a language we could all share and we could all understand each other. We're all talking about interior spaces, we're talking about space and our relationship with the space. And I already liked the experience last year, but I didn't have the opportunity, and I'm sorry for not being here yesterday. But today I was, and I'm trying to respond to one of the questions you asked, is the direction of the study, the direction of the research. I think that it's possible to combine the knowledge that was shown here, that was demonstrated here in projects. For example, Martina says, I'm interested in creating form, right? And for example, to me, I see form through color. If we can integrate all these points of view, maybe we could develop projects that would unite knowledge rather than separate it. And I'm very interested in doing research on an academic level too. So I've said this before also. The Technical University of Portugal is very open to projects of this nature. And everybody is welcome to contact me. And one of the reasons why this is so important is that we have the possibility to exchange ideas here and out there. I spoke to Cecilia and Martina out there because we can talk in the corridors and be questioned about things you never even thought before. Sometimes people ask you the most incredible questions you had never thought about them. And it's such a wonderful opportunity to listen to people who come from other areas, and because then you can link the areas through a particular thing in my case.
Question, getting into the direction of the question from Scott. For me, it's quite important in what kind of space we are living. If it's here on Earth, the main interest for me is the sociological space. It is, as an architect, if you're walking through a city, how you feel the space that is provided. If you are living in your private house, a shelter, a tent, a space. If you are traveling through space, or we are living in a space station. For me, the most important thing is the sociological space and the motion that we have as a human being through the space, and how the space is react to your own personality. If this be by color, by light, by shape, by form. For me, it's that the space can be adapt, and that the human being is creative enough to make personal interaction with the space. And I think that is what the future for me should bring. That what I feel here on Earth, what I get the notion that the cultural is getting a kind of too fast, that we are losing a kind of image in our daily life, city structures, housing. It has to be we are losing a kind of identity. And when I go walking here around Long Beach, and I think, okay, what is the identity? What we are looking for? And this identity is for me very important as a person when I live in space and feel happy in the space where I live in.
By identity, you mean the identity of Long Beach, or?
The identity of what the space is providing you. If this is the Long Beach cityscape, or if this is a closed environment capsule, the identity of this capsule, the interior design, how the design is actually providing you, stimulating you, and stimulating you for 24-hour cycles. That's for me the identity of the space.
And if I this time refer to the CRV project, we found it very interesting, the outcome of the project, as it actually changes the structure of the interior. So what we also find out was, through our volume studies, we could also give more space for the engineers. So I think that's one thing that is very important to point out, that we should be more integrated and work more closely with the engineers. And also it's good to have reference projects like the CRV, where we really can show how the ideas from us as designers and architects could influence on the whole structures and the vehicles and interiors of different habitats. There I think we have a big responsibility to really communicate that to other disciplines and try to integrate more. It would have been very nice to have, for example, like 40, 50, 60 or 100, I don't know how many seats we have here, but engineers that would find it interesting to come here and see what could we contribute to. So that is, I think it's also a very important future question for us, how we can communicate and really reach out with the ideas and goals and ambitions that we have to make a better everyday life for people living and working in space. And as an industrial designer, I also feel a very big responsibility to use the things that I learn in the area of space architecture in the everyday life here on Earth. It could be everything from volume management, how our cities is growing faster and faster, how we can work with megacities by using ideas from International Space Station in case of this, what I call volume management. Also, the life support system developed for space could be very interesting to integrate in the third world. So I think that's also important questions, and how we can use the materials and technologies developed for space into more commercial products, and then make aware more of the general public of the benefits and values that could be found in space.
Do we have any questions or comments from the
Since this is an international panel, I'd like to ask a question. I've seen a lot of very interesting designs from Middle East, Sweden, Denmark. Sorry.
No, it's one.
Oh, sorry. Do you feel there's a different type of statement that you're making as Europeans compared to what NASA does or American architects? Is there something specific about European way of thinking? And I can extend it to other parts of the world, but whatever you feel like.
He's still European.
And Mark is included because you may know about that. You were presenting design from Florence,
and the day before from Austria.
Right.
Yes.
And to comment, to give an answer on that question. A few years ago, my first visit to America, and then this longer stay in Canada, about 7 months or so. During that period, for me it was the personal feeling that by the scale of the landscape and the urban sprout that you have around you, for me it was that you are kind of slowly losing your feeling for detail. And I think looking to the European culture and looking to how the culture in Europe is built from, and even my short working period in Japan, it was for me kind of really getting a sense of the design and a certain framework, what for me personally I can use in space applications. So yes, there is, for me personally, there is a difference in European design, however you're pronouncing that, or American or Asian, and I think that's interesting to get those combinations of culture in one or in several. Actually, that you are traveling in a space station or in a space colony to the same cultural identities as we have here on Earth.
That's a very difficult question. And why is it difficult? In my case, for instance, I've lived in so many countries, Europe and out of Europe, and I don't know any longer if I'm Portuguese. But I love to be Portuguese. But I don't know if that is important. What I know is that we're working for the human being, and there must be some pattern that relates all of us in our needs. There must be something that integrates all of us, whether we come from Africa, from any part, from Asia, any part of the world. And I think we could work for the human being. But I understand that your question has another implication in terms of an era of globalization, whether we want to retain the identity or whether we want to integrate with the rest of the world.
Part of it is good. I mean, to make it very simple, if I walk into a Japanese house, I know, I'm in a Japanese house, or in an Italian house, or in Florence. Can you walk into a capsule now and say, it's an Italian design capsule?
I hope not.
Or a Swedish one?
But I don't know. I hope not. I hope it's for the human being. But maybe you can. That's why it's such a difficult.
I'm not saying that it's bad. I think it should be good, actually.
It's an interesting problem.
It's a very, very interesting problem, because on one hand, Japan wants to retain its identity, and so does Portugal, and so does any other country. They want to retain their identity. And then you have international people from all over the world that are working in space. So do they bring the heritage with them? That's basically what you're asking.
Right.
And And is that good or is that bad? That's such a difficult question to answer.
This is actually, you mentioned Japan wanting to retain their identity. In my experience with Japan, they felt that they've made a mistake taking on the Western ideals so quickly and so thoroughly that they have a nostalgia. And I'm wondering if maybe David might want to comment on that, since he's come from the Asian culture as well, and has found himself in the UK.
Well, for me, I'm also kind of international background. I spent half of my life in Hong Kong and half of my life in Europe. So I actually don't know whether I can consider myself a European or Asian. But one thing I would say is that I really enjoy the opportunities to work with different culture of people, because it's always fascinating to see like how the subtle difference of people of how people work in different culture. And I think like concerning back to like space architecture or space, I think the important thing is to design how to design the space, which is important for the quality of life. And I think people from different culture will use the space differently. That is what makes it the most important thing. I mean, you may design a very genuine space, but the space can be utilized in a different way to suit a particular culture or identity. And that's how I think about the kind of I won't say a globalized vision of space architecture, but it could be one of the directions.
Well, I don't really know what to answer to this question, but my experience is mixed too. I studied in Germany, and where the approach to design is like the opposite as in Italy. So Germany is much more concerned about functionalities, more or less like here, I guess. And in Italy, there is concern almost only about the shape of and the context and the form of the project. So I don't know. I think I try in my design to find an equilibrium between these two things.
So kind of a related question having to do with the actual international nature of our panel. Did you find, do you have any opinions on say, access to government or access to industry resources? The reason that I say that is because we all know that NASA has a very big, a great amount of these resources, and but then there's been the European Space Agency. We have these centers all over. In your own experience, do you feel that you had been in an international situation access to these resources, and what kind of frustrations did you have?
But I don't know much about that. I just got my contacts with the company Aerospace, and there is where I ask information when I need, but I don't know much about
that. I think I can go to my graduation project. It was kind of it was an architectural education, and I had this idea to make a nomadic flying object, and it was the first year that as a student you can choose your own project. So all my professors were kind of really freaking out, what are you doing? And then over my graduation project I had to search for materials for touchable projects to convince the professors from, okay, this can be done like this and this. So I really went to a huge research and connect to Aerospace University and AIAA, and to find all those connections. And I think the people are really trying to help you, as I see in your projects, where you have so much sponsoring. And if you have a good idea and a good goal, then people are really be delighted to help you and to get you on the right track.
I can only say what I said before, that from my part, I was very lucky, as Lund University already had these connections in 1997 with NASA, and that was facilitating very, very much for me. And also in the Cruton vehicle project, where also European Space Agency got really involved in the project, which was also very, very helpful. And always very good support from the Swedish National Space Force, so they are very open-minded for this cooperation with architecture and design and space. And also now when I have my own company, they are very supportive. So that's a good start, at least.
Okay, does anybody have any final comments
Yeah,
or questions?
I'd like to ask a question. How do you see, since you are all mostly connected to Europe, how do you see the role of Europe and the European Space Agency, say in the next 20 or 50 years, developing any of its own projects? I know they've started in space with the International Space Station, but do you see them taking initiatives, or from your own countries, initiatives that could be called European, or what would they be like?
The reason why I didn't answer the question before, but Scott now I asked, is that I am going to contact AIAA for a project in the future, and I believe that there is interest in these projects, particularly because there's a link between the Science and Technology Foundation and the European group, so possibly we're living in difficult times in terms of, I don't know if you feel the same, but in theory everybody finances your projects until you really ask them for the money, and then you understand that it's not exactly like that. It's more or less like that, but it's not. There's a lot of interest always, but we are living in difficult times, at least in Portugal. And so in theory there is a lot of interest. We'll see in the future how things work, but I'm looking forward to financial support, yes. Very positive.
Oh, those are the hottest words.
Yes, they were.
Can I quote you on that?
One thing I found the European community is very helpful is that, personally, as a non-European, the Europeans are generally very open on accepting people from outside their community. And I mean, as a person from Hong Kong, which basically are Chinese, and are all still able to participate a lot of European space. It's not program. I can still go to visit a lot of European space facility, or join go to conference, or a lot of things. And they are very, very resourceful to do that, and they're generally very helpful, and they they don't unlike well, I can't really say. But generally, all I would like to say is I see that as a big bonus, or big a good things for the European community, and I see that if they can keep on doing this, it will be they will have a very, very good future.
my feeling about the European initiative is that they are probably starting having interest also in design, but I don't think there are many resources for that for now. I think there are a lot of studies going on, and many more people, more and more people involved in that. But I cannot foresee what will be later.
We're all looking forward.
If you allow me, my name is Dietrich Fennemann from the European Space Agency, so it's perhaps appropriate if I say a few words here. Maybe to your question first, and then this goes on to you. We are actually in the process